Good morning to everyone. Now, in our today's session, we will start with the chapter 2, that is the acids, base, and salt. Basics of this acid, base, and salt that you already studied in your previous class. In this chapter, we will discuss about the different chemical properties of acid base, how the acid is react with different component, which type of byproduct is produced by the reactions of the acid with the different component. Now, here if we talk about the initial introductions of the acid, base, and salt, so in past the acid was detected on the basis of the taste. If acid means the substance that produces the sour taste. If the substance produces the sour taste, then it should be called as a acid, and if the substance produces the bitter taste, then it should be called as a base. This one is a common conventional thinking in past. Okay, actually it is true, but we cannot detect the acid and base on the basis of this character only. Scientists come to know, okay, it is very difficult task to determine whether the given substance is acid or base every time with the help of the taste, because some strong acid is there, strong base is there. We cannot check the taste of that strong acid, strong base. Okay, it may harmful to the tongues. So that's why the different detection method should be discovered. Now here different taste later on introduced. Here acid and base. When we use the term this acid and base, means our conventional thinking is, okay, this acid and base is present in the chemistry lab only. But actually in our routine life, many of the component is there is acidic and basic that we used. Suppose if I talk about the lemon, if I talk about the orange, if I talk about the all the citrus fruit, if I talk about the buttermilk, if I talk about the what is this vinegar, okay, this all the substance, tomato is acidic in nature. Tomato possesses the oxalic acid, vinegar contains the acidic acid, the citrus fruit contains the citric acid. So this routinely we use the different type of acid in our life. Now if I talk about the base, surfactant means powder material. Surfactant is there. So that surfactant means washing powder. So is nothing but the basic in nature. The washing powder is base in character. Suppose if I talk about the soap, soap is also basic in character. Now here sometimes we use the milk of magnesia, that is nothing but the milky solutions to treat the acidity. Sometimes we use the eno. I think so you are familiar with this eno. Eno is used to treat the acidity. So if any person suffered from the acidity, acidity means what? More quantity of acid that is secreted from the stomach. So on that time, to neutralize that acid, there is need to give the base. That base is nothing but the eno is there, milk of magnesia is there, milk of magnesia, milk of magnesia. So this milk of magnesia, this eno, this surfactant means the washing powder is the soap is the, this all is nothing but the basic in nature. And if I talk about the salt, okay, everyone is familiar term salt. Salt means the substance that is produced by mixing the acid and base. And best example of the salt that is conventionally called as a salt is the NaCl, sodium chloride, namak. So here in our routine life we use the acids, base, and salt. Now in past detections of the acid and base, that is on the basis of the taste. Later on scientists come to know every time, okay, it is not feasible to detect the acid and base by the taste only. So we should determine the new detection test. We should determine the new detection test for acid and base. Later on, the new concept of litmus test is introduced. Litmus paper is produced from litmus solution. Litmus solutions is prepared from a plant extract. Okay. Now this litmus solution is there. In this litmus solutions, we will dip the fibrous paper for the some period of the time, and later on that paper is going to dry. And that paper should be called as a litmus paper. Now this litmus paper gives the different color with acid and base, and it is the common test to identify whether the given substance is acidic or basic. Whether given substance is acidic or basic. So if acid is there, if the acid is there, that is the ABR. If the acidic substance is there, so it will convert the blue litmus paper to red litmus paper. It will convert the blue litmus paper to red litmus paper. And if the base is there, BRB, if the base is there, then it will convert the red litmus paper into the blue litmus paper. So acid will convert the blue to red, and base will convert the red to blue. Now suppose if the acidic substance is there, and if I dip the red litmus paper into the acidic substance, then what's happen? Definitely the red litmus paper remain red, is not going to convert into the blue. Red will remain red. So acid will convert blue to red and red to red, and base is convert red to blue and blue to blue. So this one is the common test for identifications of acid and base. Later on, many of the indicators that is discovered to identify whether the given substance is acidic or basic in characters. Suppose here, if I talk about the strain of curry, means curcumin is there. In simple language, we can say is that haldi. Okay, so we know that what is the color of haldi? So color of haldi is yellow. So in dry case and in acidic environment, in dry form and in acidic form, the haldi means the curcumin shows the yellow color. Curcumin shows the yellow color. But when this curcumin come in contact with the basic component, basic environment, soap is a basic in nature that we already discussed, soap powder. Okay, so when it come in contact with the basic environment, means with the soap, it will be converted into the reddish brown color. It will be converted into reddish brown color. Okay, so this is characters of what we can say is haldi. Okay, curcumin. Now, second indicator, that is the methyl orange and phenolphthalein. Second indicator is the methyl orange and phenolphthalein. These two indicator is commonly used in chemistry lab to identify whether the given substance is acidic or basic. Acid base titration that done with the help of these two indicator. One is the phenolphthalein and second one is the methyl orange. Now, what is the color change that we observe with phenolphthalein and methyl orange? So, if I talk about the phenolphthalein, if I talk about the phenolphthalein, so phenolphthalein will convert colorless to pink color when basic environment is generated. In other simple sense, we can say is that if the acid is there, phenolphthalein is colorless in character, and if base is there, then phenolphthalein will produce the pink color. So if I add the two drops of the acid, if I add the sorry, two drops of the phenolphthalein in acid, then it will show the no color, no change in color. And if I add the two drop of phenolphthalein in base, it will show the pink color. Okay, here we can see here, see here. So methyl orange produced the pink color in the acidic environment and yellow color in basic environment. So this two is the most common indicator to identify whether the given substance is acidic or basic in character. Here one activity is given. In this activity two example is taken and we will perform the litmus test and phenolphthalein test and methyl orange test with these solutions, and we will decide whether the given substance is acidic or basic. So substance is hydrochloric acid is there, sulfuric acid is there, nitric acid is there, acetic acid is there, sodium hydroxide is given, calcium hydroxide is given, potassium hydroxide is given, magnesium hydroxide is given, and ammonium hydroxide is given. So here name itself indicate that whether the given substance is acidic or basic in character. But suppose this all the substance is given as a dummy name, means substance 1, substance solution A, solution B, solution C, solutions D, then we will perform the sample test. Suppose the sample number 1, what is the change in color? It will convert the red to blue or it will convert the blue to red. It will colorless in nature or it will produce the pink in color. It is pink in color or yellow in color. Okay, so this all the test that we will perform, and on the basis of that we come to the conclusions. Here the given substance A is there, substance B is there, is acidic in nature, substance D is basic in nature. So in this way we can decide whether the given substance is acidic or basic without checking the taste of that substance. Okay, so this is the most commonly used indicator for detections of the acid and base. One more is that is the olfactory indicator. Olfactory indicator means what? Olfactory indicator means it related to the smell, is related to the odor. Okay, here it will produce a different odor with the acid and base. If the acidic is there, it is produce some specific odor. In base is there, it will not produce the odor, otherwise it may produce the some different odor. Okay, so if the odor, if the smell is going to change according to the acidic medium and basic medium, then this type of substance can be used as a olfactory indicator. So here the most common olfactory indicator, that is onion is there. Onion is the common olfactory indicator. Now here simple activity is given, that is finely chop the onion, then pack it into the plastic bag. Okay, later on that onion, means finely chopped onion, is placed over the cotton cloth. It will be packed into the cloth and packed it and placed for the specific period of the time. Later on, remove that onion and take the two strip of that cloth, means जो भी cloth है उसको दो part में divide कर दो and check the order. दोनों के order check कर दिया, दोनों में onion का smell आ रहा है. Now here keep them on the clean surface and put the few drop of the dilute HCl and few drop of the NaOH. HCl is act as a acid and NaOH is act as a base. Okay, so here when we perform this test, in one case the smell is remain as such, while in other case the smell is completely vanished. Smell is completely vanished. Okay, so odor in acidic medium, odor is remain, and in basic medium odor is completely vanished. So this type of result that we received, so this onion should be called as a olfactory indicators. The same way vanilla is there, is also act as a olfactory indicators. Okay, vanilla also shows the color with acidic medium, and in basic medium it will not shows the color. Clove oil also same. Okay, so here this three, onion, vanilla, clove oil, is called as a olfactory indicators. Okay, so this is about the olfactory indicators. Here check that observations, आप घर पे भी चेक कर सकते हो कि whether olfactory indicator work properly or not. Okay, क्या स्मेल में क्या चेंज हो रहा है वो आप घर पे भी चेक कर सकते हो. Now here, before going to the chemical properties of the acid, means reactions of the acid with the metals, with the base, with the water. Okay, here first we will understand the basics of the acid. What is the acid? Means here, if the blue litmus paper is converting to the red, then the given substance is the acid. If the red litmus paper is converted into the blue, then given substance is base. So this one is the observation based definition. It is the observation based definition. But actually, what is the acid? Which substance shows the acidic property? Actually, which special chemical formula is there? Which special ion that is present in the given substance that is responsible for the acidic characters of that substance and basic character of that substance? So actually different theories is there for the acid base. In that, main three well-known theory is there. One is the Arrhenius theory. Second one is the Lorry-Bronsted theory. It is also called as a Bronsted-Lorry theory. And third one is the Lewis theory. Okay, this all the theory that you will study in the 11th 12th standard. The most common and oldest theory, that is the Arrhenius theory. That is Arrhenius theory. Now according to Arrhenius, what is the acid? So according to Arrhenius, when any substance dissolve in water, in other sense we can say is that when we make the solutions of the substance and it will produce the H plus ion, sorry, it will produce the H plus ion in water, it will produce the H plus ion in water, then given substance should be called as a acid. If it produce the H plus ion in given solution, then it is called as a acid. And if it is produce the OH minus in water, then it is called as a base. Okay, here just see here, this one is the acid and this one is the base. Okay, means it will produce the OH minus in. So you come to know what is the acid according to Arrhenius theory. There is no need to discuss about the Lorry-Bronsted theory and Lewis theory. So acid means they possess the H plus ion, and base means they possess the OH minus ion in water. H plus ion produced in water only, OH minus produced in water only. If the water is not available, then it will not produce the H plus ion, it will not produce the OH minus ion. So acid can act as a acid in the water environment, means in the aqueous environment. Base can be act as a base in the aqueous environment. In the dry form, it cannot be act as acid, it cannot be act as a base. So that we will discuss later on. One topic is there, interesting topic. So this is about the acid and base chemically. Okay, now here we will discuss the reactions of the acid with the metal. So how the acid will react with the metal. So here one activities is given. In this activity, simply what we will do, we will take the zinc granules. We will take a zinc granules in a test tube. Now in this zinc granules, we will close with the rubber stoppers. Now we will add the acid. Okay, that acid, it may be HCl or it may be H2SO4. HCl is called as a hydrochloric acid and H2SO4 is called as a sulfuric acid. Any acid can be added. Okay, here H2SO4 is added in this activity. The same result that we receive with the HCl also. Okay, so here H2SO4 is added. The test tube is in the closed conditions. The reaction between H2SO4 and zinc granules is occur, and some gas is going to produce. Some gas is going to produce. That gas is passed through these delivery tubes, and here at the bottom soap solutions is filled, and this tube is deep into the soap solutions. So when the gas is released into the soap solution, so definitely bubbles is formed, and that bubbles is moved to the upward direction. Why? Because the density of bubbles is comparatively less, and whatever the gas is there, that gas density is less. Now which gas is produced? If you want to check by the activity, then simply here when we place the candle nearer to the gas, we observe that bubbles will produce the pop sound. Means we can say is that the gas present inside the bubble is combustible in nature. The gas present uh, inside the bubbles is combustible in nature. Means gas is used as a fuel. So here if we check the activities chemically, which gas is produced, so reactions wise, here Zn is there. This Zn is react with the H2SO4. This Zn is react with the H2SO4, so it will produce ZnSO4. It will produce the ZnSO4 plus H2. Okay, here from these equations, okay, you come to know which type of reactions is there. Actually this is the displacement reactions that we already discussed in our chapter 1. This is the displacement reaction. Means Zn will displace the H2 and ZnSO4 is produced, and H2 gas is going to produce, and hydrogen gas is combustible in nature. So when any metal react with acid, when any metal react with acid, it will produce salt of that metal plus hydrogen gas. It will produce salt of the metal plus hydrogen gas. So these reactions, this type of reactions that we observe with HCl with H2SO4. Okay, here some of the strong acid is there, it will produce the quick productions of the hydrogen gas. If the weak acid is there, if the weak acid is there, like citric acid is there, that is present in the citrus fruit, like the oxalic acid is there, that is present in tomato, like the acetic acid is there, that is present in vinegar. This is the weak acid. This weak acid can produce the H2 gas, but the rate of production is very less. And these are the strong acid. The strong acid can produce the acid quickly. Three main strong acid is there. One is HCl, second one is H2SO4, and third one is HNO3. The mineral, this strong acid is also called as a mineral acid. H2SO4, HCl, and HNO3. Nitric acid. Nitric acid is there. So these three acid is considered as a strong acid. So this acid produce the large quantity of H2 gas, means productions rate is too high with this acid. But when we check the study with the HNO3, we cannot produce, we cannot receive the H2 gas. Why? Because this HNO3 is strong acid as well as is strong oxidizing agent, is the strong oxidizing agent. Oxidizing agent means what? Oxidizing agent means the substance that can oxidize the other. Itself is undergo the reduction. Itself it undergo the reduction, but it will oxidize the other. Means suppose if I am the passport agent, so I will make the passport of others. I will not make the passport of mine. I will make the passport of others. So here oxidizing agent means the substance that oxidizes the other. So HNO3 is the strong oxidizing agent. So when the H2 gas is produced, quickly that H2 gas is oxidized and it will be converted into the water molecule. H2 gas is converted into the water molecule. Means oxygen is going to added into the H2 and it will be converted into the water molecule. So that's why HNO3 is not capable to produce the H2 gas in large quantity. No doubt, if the weak process is there, slow process is there, slightly very few quantity of H2 gas can be produced, but maximum quantity of H2 gas is converted into the water molecule because of oxidations of the uh, H2 gas. Okay, so here these two strong acid produce the hydrogen gas while the HNO3 is not capable to produce the hydrogen gas. Hydrogen gas is going to produce, but it is converted into the H2O. Okay, so see here the metal in above reaction displays the hydrogen from the acid and it will produce the hydrogen gas. Okay, here the reactions is given acid plus metal gives the salt. Okay, plus hydrogen gas, right? Side by side here some metal produce the hydrogen gas with base also. Some metal produce the hydrogen gas. Generally metal can produce the hydrogen gas with acid. All the acid can produce the hydrogen gas with metal, but base is not capable to produce the hydrogen gas with metal, but few metals is capable to produce the hydrogen gas with the strong base also. Strong base means what? Which are the strong base? So KOH is there, potassium hydroxide. NaOH is there, sodium hydroxide is considered as a strong base. So the metal, few metals is capable to produce the hydrogen gas with the strong base. The example of the metal, that is the zinc is there, aluminum is there, zinc, aluminum. This metal is called as a amphoteric metal. Is called as a amphoteric metal. Amphoteric means what? Amphoteric means has a characters of acidic, basic, means it can react with the acid also, it can react with the base also. So it can be react with the acidic material also, it can be react with the basic material also. So zinc, aluminum is considered as a amphoteric metal. So react with the base also, react with the acid also. When it react with the base, it will produce the sodium zincate, sodium aluminate, and H2 gas is going to produce. So this is about the reactions of metal with acidic substance. Now next one, that is as reactions of metal carbonate and metal hydrogen carbonate with the acidic substance. Metal carbonate and metal hydrogen carbonate. Okay, so here if we talk about the metal carbonate, so Na2CO3 is there, sodium carbonate, NaHCO3 is there, that is the sodium hydrogen carbonate. वैसे ही हम CaCO3 लिख सकते हैं, K2CO3 लिख सकते हैं, KHCO3 लिख सकते हैं. So different example of metal carbonate and metal hydrogen carbonate is there. Now when they react with the acid, when they react with the acid, it will produce the gas, but that gas is not a hydrogen gas. That gas is other than hydrogen gas, means here CO2 ion is there. CO2 ion is there. So this CO3 ion. CO3 ion is there, and this CO3 ion will produce the CO2 gas. Will produce the CO2 gas in this activity. Okay, so here the interesting experiment is that here very interesting experiment is that simply what to do. Okay, we will take one test tube. In test tube we will take the few pieces of the sodium carbonate, and later on we will add the dilute HCl is there, otherwise the dilute H2SO4 is there. Reaction is that some gas is produced. That gas is passed through these delivery tubes, and it is directly enter into the CaOH twice, that is called as a slake lime. CaOH twice, calcium hydroxide solution. Calcium hydroxide solutions is a soluble solution. Is a soluble solution. But when the CO2 that is enter into the calcium hydroxide solutions, here the reaction is occur. Which type of reactions is occur? This is the reactions. When the CO2 come in contact with the calcium hydroxide, it will be converted into the calcium carbonate, and this calcium carbonate is insoluble in character. This calcium carbonate is insoluble, so white precipitate is formed. So as the gas enter inside the test tube, here the white precipitate is formed, indicate that the CO2 gas is going to produced in this reaction. So Na2CO3, when it react with the HCl, otherwise H2SO4, it will produce the NaCl plus water plus CO2. So when the acid is react with the metal, it will produce the salt plus hydrogen gas. And here when the acid is react with the carbonate compounds, it will produce the salt plus water plus carbon dioxide. It will produce the salt plus water plus carbon dioxide, and this carbon dioxide is detected by this test. Directly we will pass the carbon dioxide into the calcium hydroxide solutions. It will produce the insoluble precipitate, that is the calcium carbonate. Now here when the few very trace quantity of CO2 enter into the solution, it will produce the white precipitate. But if the large quantity of CO2 is enter, then this insoluble substance is converted into the soluble substance. Why? Because this calcium carbonate, when the calcium carbonate receive the more quantity of carbon dioxide in presence of water, it will be converted into the calcium hydrogen carbonate. See here, it will be converted into, when this calcium carbonate receive the more quantity of CO2 in presence of water, it will be converted into the calcium hydrogen carbonate, CaHCO3 twice. It will be converted into the calcium hydrogen carbonate, and this calcium hydrogen carbonate is soluble in nature. So it will be converted into the soluble. So CO2 गैस पास हो रहा है तो वो इंसॉल्यूबल ही रहेगा, ऐसा नहीं है, इनिशियली इंसॉल्यूबल हो जाएगा अगर वो डिटेक्शन पॉइंट में आपने चेक नहीं किया है और कंटिन्यूअसली CO2 पास हो रहा है, तो एक स्टेज आएगा कि वो इंसॉल्यूबल सॉल्यूशंस फिर से सॉल्यूबल फॉर्म में कन्वर्ट हो जाएगा. तो पहले सॉल्यूबल था, इंसॉल्यूबल हुआ और फिर से सॉल्यूबल हो जाएगा अगर CO2 कंटिन्यूअसली उसमें पास हो रहा है और आप चेक नहीं कर रहे. आपने एक्सपेरिमेंट सेट करके रख दिया और देख लिया कि नहीं अभी CO2 जाएगा, इंसॉल्यूबल होगा, मैं जाके आता हूँ, कहीं घूम के आए, तब तक CO2 प्रोड्यूस भी हुआ, इंसॉल्यूबल भी हो गया और सॉल्यूबल भी हो गया, और आप आओगे देखोगे कि नहीं ये तो सॉल्यूबल है, मतलब इसमें CO2 गैस प्रोड्यूस हो रहा नहीं है. तो इट मे क्रिएट द मिस इंटरप्रिटेशंस. Okay, so when the few quantity of CO2 gas that enter into the solutions, it will be convert the soluble slake lime, soluble calcium hydroxide into the insoluble calcium carbonate, and this insoluble calcium carbonate convert into the soluble calcium hydrogen carbonate if the more quantity of CO2 pass from the uh, solutions. Okay, calcium carbonate solutions. Now here this one is the common metal carbonate is the metal hydrogen carbonate is the is react with the acid, it will be produce the salt plus carbon dioxide plus water. Many other reaction is there that we can discuss. Okay, here only the example of the sodium carbonate and sodium hydrogen carbonate is there. We can set the many of the reaction on the basis of these uh, chemical properties. Okay, so here this is about the reactions of metal with the metal hydrogen carbonate and metal carbonate. Now reactions of the acid or base with each others, that we will discuss in our next lecture. Okay, so thank you very much.